In principle, the overall result of the response modeling is the so-called damage susceptibility profile. That means that for a certain set of elements exposed to the hazard process, we are able to, let's say, describe the possible scenarios of damage generation mechanisms, and based on this we can proceed to the next step, which is the damage accounting steps. That means that starting from a rather detailed idea of what might happen under certain conditions, we can infer, we can quantify the damages in terms of altered situations, failures of protection systems, for example, destruction or severe damaging of residential buildings, failure of transport connections, failure of other networks, and so on. And based on this, we might be able to compile a description of the adverse consequences in terms of direct and also indirect damages. Here, I have to admit that, let's say, mathematical modeling approaches exist, but let's say that there are a lot of open issues how to best apply these modeling techniques in the field of natural hazard risks. Research is going on in this field, but let's say for the standard professional domain, still no modeling framework is available to perform this rather complex task. But if we imagine to conclude the whole chain of modeling steps, we have a fifth modeling phase, which is the economic valuation. That means in detail to quantify in monetary terms the losses in terms of reinstatement values. We imagine that if we imagine that we have to bring back the situation towards a state prior to the perturbation, prior to the impacting effect of a natural hazard process, and we imagine to reconstruct the damaged parts, we can determine the reconstruction value or the reinstatement value. Other approaches take into account the quantified damages, or the, if you want, the paid amount by the public hand to compensate for the damages. There are different ways to quantify in monetary terms the damages. It works quite well for direct damages and tangible damages. For indirect losses, this valuation approach exhibits a certain number of weaknesses. So for indirect damages, probably there are more suitable techniques linked to the determination of altered flows of costs and benefits throughout a network, or how economists deal with such problems through input-output modeling, and somehow taking into account different transformation factors in this input-output modeling in order to quantify, let's say, if you want, an altered economy. This works quite well if the natural hazard process has a rather significant scale, on a more small scale, probably we have to look into more detail which network alterations can be associated to a certain damage profile. For example, which road networks are cut off if a bridge is going to be severely damaged, or which business processes cannot be fulfilled if, for example, important productive infrastructure fails under the subjected to the loadings of a natural hazard process. So also the economic valuation is not always straightforward. We have to apply, if you want, a certain deal of expert judgment and also a certain flexibility, methodological flexibility, to come up with quantified numbers in terms of values for these losses. So the point here is that the dream of modeling in a numerical mathematical fashion all these process chains obviously persists, and research is trying to develop such modeling tools. However, currently there's still the need of using expert-based scenarios, for example, to align the modeling results of the single phases, for example, to, if you want, translate impacts into responses, or to determine for each object the boundary conditions starting from the information contained in process intensity maps and so on. So scenarios might be needed to align modeling results. In addition to this, where modeling lacunae persists, where there is the need to develop a modeling approach to come up with accurate and precise results, but this modeling approach is still not available for advanced hazard assessment or advanced risk assessment. In this case, we can substitute for by using scenario building techniques in order to structure the available knowledge and to close, if you want, the problem, and in order to be able to proceed along this modeling chain. So scenarios are also used to structure knowledge where numerical mathematical modeling approaches are missing. So based on this consideration, I would invite you to, in the remaining time of this first lecture, to approach the following exercise. I sent you two papers. One paper, the paper by Wieck and Iwaniec, is a paper that deals with the so-called quality criteria for visions and visioning in sustainability science. This is the paper that deals more with the conditions for successful planning in a sustainability context. The second paper is a paper dealing with more methodologically with constructing risk scenarios starting from the available knowledge. And this is a paper that deals more with the restricted, if you want, domain of natural hazard risk assessment. In either case, I invite you to read the papers, build two groups. One group deals with the first paper and one group works with the second paper. And as a task, I would like to invite you to answer the working question as and the group. It should be a result of group work, and also in this group work you should reflect a bit the ideas of the single components of the group, and you should somehow be able to send me your results in written forms before the next lecture. So for the first paper, the question sounds like this. Can such quality criteria, that means this criteria to that have the objectives to specify better visions and the visioning process in sustainability science, can such quality criteria for visions and visioning enhance planning processes? Supposedly yes, but also it would be interesting to know how. And please add also an example that might illustrate exactly the different ways how such quality criteria might enhance the planning process or planning processes. You can also define in your example certain, you do not need to deal with the whole sustainability problem. You can somehow dissect a smaller problem and deal with this smaller problem. But it's important that you reflect about this listed and described quality criteria. In the second case, the task is straightforward. Can hazard and risk assessment be enhanced by consistent scenarios? Provide examples. I think that here the answer is obviously yes, that these scenarios, that this hazard and risk assessment can be enhanced, but please go a bit into detail. Think about this so-called lacune, this so-called missing domains where numerical mathematical modeling does not deliver, if you want, useful results, or where still research is needed to come up with fully reliable modeling approaches. And in this case, obviously, expert knowledge is needed to come up with a complete risk assessment. But if we are able to structure, if you want, this expert knowledge in form of scenarios, and if you read the paper, you get a first idea how these scenarios can be structured, probably at the end there are net benefits for the risk assessment. So I will be happy to read your answers and your reflections. Do not be afraid to choose the first paper, because we have also to keep open, let's say, the door, the flexibility to the planning process. Not only thinking, we do not only think about hazard and risk assessment, we make a step forward also to the planning process, because I am convinced that a student from Bocconi University should be able to enter in a, let's say, in a very convinced and decisive way also, if you want, in the labor market, also for planning tasks. Let's meet us again in the next lecture, and I will try to do my best to prepare to enhance the videos in order to enhance the overall outcome of this course. Thank you very much.